So our last example demonstrates how these types of problems may be used. Suppose a company sells two types of laundry detergent, bleach and lavender scented. Let X represents the number of bleach bottles sold each year in millions, so let's write that down. And Y represent the number of lavender scented bottles sold each year in millions. Suppose their yearly revenue in millions of dollars is modeled by R of XY equals negative 0.5x squared minus 0.8y squared plus 3.9x plus 3.9y minus 0.2xy. So again, R is the revenue in millions. So we want to determine the number of bleach and lavender scented bottles that must sell in order to maximize revenue, and then find what that maximum revenue would be. So let's start by finding each of our partial order derivatives. We'll take the first with respect to X, and then the second with respect to Y. And remember, we're going to use these two to find our critical values, which means we'll end up setting these equal to 0. But let's go ahead and find our second order derivatives because we know we're going to need those later. So with respect to X and then X, we will get a negative 1. Y and Y, we will get a negative 1.6. And X and Y, we will get a negative 0.2. So now let's find our critical values. We're going to take that first derivative with respect to X and set it equal to 0. So putting that in order, we would get a negative X minus 0.2y equals a negative 3.9. And then the other derivative with respect to Y, putting these in the same order, we get negative 0.2x minus 1.6y equals a negative 3.9. And we can call these equation A and equation B. So let's multiply equation A by a negative 0.2. That's a negative 0.2 by A. And we would get a positive 0.2x plus 0.04y equals 0.78. We're going to leave equation B the same, combine our like terms, and we end up with y equals 2. And now we can plug that into any of our equations to solve for x. I'm going to go ahead and use equation A, the original. So we have a critical value at 3.5 and 2. Okay, let's scroll up a bit here. So we have found our critical value after we've done all of the derivatives. Now our next step, if you recall, is to find our D value. And remember, the D is second order partial derivative, x and x, times the y and y, minus the mixed squared. So using our values up in the top right there, we will have a negative 1 times a negative 1.6 minus a negative 0.2 squared. That gives us a positive 1.6 minus a positive 0.04, which will still give us a D value that is positive. That's the important part. It's greater than 0. We also know that the second order partial derivative with x and x is less than 0. Remember, when the second derivative is negative, that means it's concave down, and we have found a relative max, which is what we wanted. We wanted the maximum revenue. So we can scroll back down. After we have found our D, let's recall that our critical value had an x of 3.5 and a y of 2. So we need to find what our revenue R is with that x and that y value. So we're going to plug it in back into the original equation. Let me write that equation again just so you can see it on the same screen. And now let's plug it in. And if we put all of that into our calculator correctly, I believe we get approximately 10.725. And remember, this is in millions. So how do we interpret this? We need to sell 3.5 million bottles of bleach and 2 million bottles of lavender scented detergent to maximize our revenue at $10.725 million.